video, we're going to be talking about linear and nonlinear functions, and specifically how to tell if a function is linear or nonlinear. So what does it mean for a function to be linear? Well, it means that it's a straight line. So if we look at the graph, it's a straight line. We have a straight line. And it also means to increase by the same rate, or by a constant rate. We call that a constant rate of change. Now, if something is nonlinear, then it's not going to be making a straight line. It's going to have a curve in it. And it's going to be increasing by different rates for each change that we see. Let's do an example. So here we're going to copy and complete each of the tables for the sequence of these similar figures. So in parts A and B, we're going to use the rectangle that we have shown here that has a width of x and a length of 2x. We're going to graph the data in each table and decide whether each pattern is linear or nonlinear and justify our conclusions. So part A, we're talking about perimeters of a similar triangle. So remember, a perimeter is where we add all the sides. Add all the sides together. In part B, we're going to be doing the areas. So remember, the area formula for a rectangle is base times height. So let's go ahead and let's look at letter A. So here it's saying when x equals 1, what would our perimeter be? Well, if x equals a 1, we'd have to plug a 1 into this spot and a 1 into that spot, giving us a width of 1 and giving us a length of 2. And so we have 2 lengths and 2 widths. To be able to add up, okay, we'd have 1 plus 2 plus 1 plus 2. So here, if our length was if our x value was a 1, we would have a perimeter of 6. Now, if our x value was a 2, we plug a 2 in there, and here we'd have 2 times 2, which is 4. So we'd have 2, 4, 2, and 4, which would give us a perimeter of 12. If we had a 3, then 3 times 2 is 6. So we have 3, 6, 3, and 6. And that would give us a perimeter of 18. If our x value is a 4, 2 times 4 is 8, so we 8, 4, and an 8. And that would give us a perimeter of 24. If it was a 5, then we have 2 times 5, which is 10. So 5, 10, 5, 10. That would give us a perimeter of 30. So now we can graph that. So at 1, we had a value of 6. And at 2, we had a value of 12. And at 3, we had a value of 18. And at 4, we had a value of 24. And at 5, we had a value of 30. And if we go ahead and we connect those right here. Let me try that one more time. Our graph would look something like this. And so here we see that we have a straight line, but we can also see that each time we add 1 to our x's, for each time we add 1, we're adding 6 to our p-value. So each time we have a change of 6 over 1, each time. And so there we have a constant rate. So constant rate. So for my rate, I put my p over my x. Constant rate of 6 over 1. And so we're saying that this is linear. And we have 2 things, right? Our constant rate and the fact that our line is straight. So let's go ahead and let's look at, what if it was the areas? So if we had an x a value of 1, we have 2 times 1. If we plug this in, so we'd have area equals the base of 2 and the height of 1, so we'd have a 2 there. So what if we used x equals 2? That would be a 2, and this would be 2 times 2, which is 4. So here, our base would be 2, or excuse me, our base would be 4, and our height would be 2, giving us a value of 8. Well, if our x value is 3, then we'd have 3, and then 2 times 3, which is 6. So here we would have a base of 6 and a height of 3, which would give us a value of 18. And if x was 4, then we'd have a height of 4, but our base would be an 8. So we plug that in, we'd have our base times our height, which would be a 32. And lastly, if our x value was a 5, we'd have a height of 5, but our base would be 10. And so here we'd have a base of 10 times our height of 5, which is 50. So as we go to graph this, we see that we would have a 2, and then we would have an 8, and then we would have 18, and then we would have 32, and then we would have 50. And so as we look at this, we're going to see that our graph kind of curves. So let's go ahead and let's check our rates. We can see that we've got that curve. So here we see that as we increase by 1 each time, on our first set we increase by 6. But on our second one we increase by 10. So automatically we see that we don't have constant rate. So our first one was a 6 over 1, but the second one was a 10 over 1, and those aren't the same. So here we see that we do not have a constant rate of change. So that's another reason why this pattern is going to be considered non-linear.